this fan motor. This is a pedestal fan that you would normally use in a factory or something like that. This one was dug out of the garbage. Looked brand new. It was dug out of the garbage just for curiosity. It's not mine. And the three-way switch, the switch to turn it on and off and to the different speeds was cut out and thrown away or something, I don't know. But it didn't have it with it. So the only thing it has back here is the capacitor and then your wires coming out of the motor. This is my little cheat cable here. They cut the cable off it too, the power cable. So I attached this back to the wires that actually go to power the fan. I had took these all apart. They did have these little crimps holding them together, but I already took this motor apart one time, so I had to take those off because the wires have to feed through this little hole right here, and it wasn't going to fit. So, and then I labeled everything, make sure I got it right back together again. So we're just gonna, I just want to go through this and kind of explain how I found, you know, if there's anything wrong with it or not, or when I first turned this on, it has power. When I first turned it on and I tried to go through the different speeds with my wires here, it seemed like it was spinning the same on all three speeds. So, you know, I checked the windings, make sure they weren't shorted to the common or anything else, and everything was fine. So these are the common, so you would connect a meter or whatever you have to test it, test the coils from here to each one of these, which are, the red is the low, black is the high, and blue is the medium. And we have two over here that have two wires coming out of the motor, and the other two black wires here actually go to the capacitor, which is a 9 microfarad, and this tested okay. So I can undo these real quick, and then we can test that capacitor just to show you a little Anatech blue capacitor tester, blue meter. Let's see, short up this, reset that. One side of the capacitor, the other side of the capacitor. That's a 9 microfarad at 350 volts. So 350 volts is way over here, and it says 9, which is way up here between. You got to understand this, the drawing here, but it says between 5 and 10 microfarads in this range for, let's say, a 350. This display right here can read up to 10 point something, even more than that, 20, probably 50 point something for ESR, but you can see it only reads 0.1, so it reads way down here. So it's definitely good. So we have no problem with the capacitor. Doesn't matter which wire you hook them back up to. I labeled them 1 and 1, 2 and 2, so far. That's just because that's the way I am. I forget sometimes. So, if we power this up, all I have to do is connect this my little jumper cable to the white ones, which are the common. The common meaning it connects to each of the 3 coils in here for the 3 different speeds. The capacitor, of course, is the help to start the motor from spinning. If you don't have that connected, this won't spin, because it needs some extra juice to help it out. This one here, let's see, I'm sorry I did that wrong. I'm connecting this to the black wire that's coming from our power cord. This will be our 120 coming in, 115, whatever this is here. And then we're going to touch each one of these, and you should be able to tell the difference with this spinning, but like I said, I couldn't, but I found a way how to figure it out. So I'm going to plug this in. Now this is live, so this is supposed to be low. So you can see it spinning. It's kind of, the motor's kind of noisy too. My conclusion to this is that I think the bearings are bad in it. So I went ahead and ordered bearings for it. I don't have them yet, but I will the next session here. This is the medium. You can hear the different sound in the motor, but it's hard to tell just looking at it, not having it connected to the fan blades itself. And then here's high. So now the way I figured out that they were going different speeds is I just measured the current that each one was drawing, and I can give you a quick show of that here. Unplug this first, connect my meter from the input, and then I'm going through my meter, and then I'm going to touch each one of these, and we'll get a different readout for the different speeds on here. I have this set on AC amps. My other fuse in here is blown, I just haven't changed it yet, but I'm on the 10 amp setting, because our milliamp setting one here for the amps is, it won't, it'll blow that fuse. Plus, you know, we're measuring AC, so we want it on 10 because it's going to be 1 point something amps. So, alright, so let me plug this in. And I'll do the low. And we read about 600 on there. And it looks like you can read it on the camera. So that's on low, so that's about 600. It's 0.600, so it's not over an amp. The specs say that it will read, all 3 of them will read 1.5, 1.6 something, and 1.9 something, but I don't have the fan on it, the blades on it, so there's no drag, so it's not forcing it to draw more current to keep it going. So these numbers will be lower than what the spec is. And once I get this all together, we'll put the fan blade on there, and we can do this same test, and then we'll see the difference in what it is. So here's the medium. Medium is right around 0.79 amps, so it's under an amp. And then the high is 1.176 amps, so that one makes it up to at least an amp. But can hear the motor is awful noisy, and when this spins you can hear the bearings are not in the best shape. This fan must have overheated for some reason. Maybe the blade was stopped or something, but it was all the grease from the sealed bearings got so hot that it oozed out of the bearings. Because when I took this apart, it was, I could see the grease laying on the inside. So that's why we're going to replace the bearings, because they sound like they're grinding once in a while, and they're not flowing, they're not spinning quietly and as smooth as what they should be, I think. So there we measured the current on each one of them, and there's another way you can do it too. If for some reason you don't know which ones are the high, medium, and low, because this didn't have a switch, I didn't know which ones were. I figured out that these 3 wires were the 3 different speeds, but you can also take your ohm meter, put it on the common. So this common here is the opposite end of all 3 of these. So when I connect this to this side, and then I take my other one and I connect it to any one of these, this is the low, and it reads 16.2 ohms. Okay, the medium is 13.3 ohms, and the high is 10.3 ohms. So the low was the highest ohms, the medium was the lowest, or the second lowest, and then the high was the lowest ohms, so less resistance. So that's another way how you can tell which one is the high, medium, and low. And I happen to have a 4-position switch. Looked through my junk box and I found a 4-position switch that is purposely for switching something like this. And you just stick the wires right inside on both sides. So you'll have you have L, 1, 2, 3 on the back of this. So your line would go here, your hot one, and then each of your speeds will connect to these here. So when you turn this, it goes to the different speeds, and you turn it all the way this way and it'll shut it completely off. So we're going to connect that up. So I'm glad I found that in my stuff. So let's take this thing apart just to get it ready for the bearings. Get my tape ripped up here. So we don't need to take the back off because this will all come right out the front, and there's nothing back here that you won't see that's in this side. So we'll look at it through this side here. There's just 4 screws. 1, 2, 3, 4 screws. These are the mounting screws for when you connect it to the cage. Alright, so there's that. Now I just take something, and I don't go at it real crazy like or anything, but I got to pop this loose. You can see now I got a gap in there, so and that's all it takes to get this loose. The bearing bearing sits right inside here, this area right here. So it's a little wet because I actually put some oil on the inside the bearing there just to keep it lubed a little while I was playing with it, but it definitely isn't something you want to do and let it run, because the oil drains right out and you'll be running on bare bearings. So the inside here, this just lifts right up, comes out, and there's down here in the bottom, way down on the bottom, there's 3 washers for shimming on this. I got 2 white ones, and then I got 2 white ones and I can't remember what the heck the name of those are right off the top of my head, but that holds, it's for pressure, so when this is inside there, it pushes up against that bearing to keep it so it doesn't go back and forth like this, so it takes out the slop in the whole setup. So that's what that wavy washer is for there. But this here, I looked at this and I don't know if this was done at the factory or what, but somebody was being a little careless, because you can see that one's bent up, and there's a couple other ones on here that that just don't look the straightest. I don't know if they did that at the factory or what, but spin the bearings, they should feel smooth. That one's not bad. Yeah, right now they're not bad because I put that oil in there, but when there's actually weight on them, you can hear that they're loose inside there. You can wiggle them back and forth like that too, and if you got a lot of slop in there like that, them bearings are loosening up. But those are what we're going to be changing. There's a little C-clip on the inside for a stop for when you push that bearing on. It runs into the C-clip. Same as on this side here. There's a little C-clip in there for when you slide this bearing on there, it stops it right in the right spot. So I'm going to have to talk with some people and see if we can't find a bearing puller or some way to get those off there, because I don't have one in my possession. But so that's that. Not much else going on in here besides all the windings. There is a on the other side, on this side, there is a thermal switch inside there. That's good, of course, because we're actually able to power this up. So the thermal switch is good. Other than that, there's it's just your basic motor, nothing much to it. So I'm gonna set this aside for now, and then once I receive the bearings, then we'll go ahead and throw this thing back together and test it out with the blades on there and see what happens. Alright, so let's see if we can get these bearings off here. I was able to acquire a puller. Hopefully this one works to get the bearings off. We'll soon find out. I have to get those C-clips off here first. And of course I'm going to do it the way that abuses my own screwdrivers. So you can do it however you see fit to get them off. I'm just hitting one side at a time to push it around the shaft to lift it up, so then I can pull it off. the same with the other side. I was hitting this, putting the screwdriver right on this edge here and then hitting it to hit it away from the shaft. So let's do the same on this other side. I'm sure a hammer would do a better job than another screwdriver, but that's what I have laying here right this second. Once you get it up out of the groove, then you can just get the screwdriver in there and start prying up on it. Don't pry on these right here, you'll break them things right off. So, there's the other one there. Alright. Now I haven't used one of these in probably forever, so this is something that we're going to both try together. Let's do this side first. Try to get it in as far as you can to grab the center race and not just the bearings, because otherwise you just pull the bearings off out of the, you just deform the bearing itself. But so I'm trying to get it in there as far as I can. And working around these little fin things here on the side too, so it might be easier with just a two grips here, but I have this one, so we're going to try it with this one. Let's see. So this is how I have it on there. Hopefully you can see that. It's on the inside race, so it pulls up the center race on the in there. Puts all the pressure on that instead of on the outside of the bearing. Something's moving, but I don't see what yet. It looks like the bearing is moving. I can see more of the groove that the pin was in. It's a little tough on your hands when you're doing it like this, but it has to pull that bearing straight off so it doesn't gouge into the shaft. And you'll get to a point to where it'll just pop right off, because the upper portion of the shaft should be smaller than the diameter of where the bearing sits. That's my guess. So you can see where the bearing was in that little groove. That's how much I've moved it that way. So it is working. We're doing good. And it's pretty easy right now. You can see I'm turning it pretty easy. Well, that's it. And we got it off. Well, we're getting there. It's off of where it's supposed to be, but there must be a burr right here. I think I can feel one. Let's see if I don't know if I got some sandpaper laying around here. There we go. Voila. And you can see where the bearing sits right there. So these bearings, I'm pretty sure I mentioned in one of the other segments for this video that this fan got really hot and it actually not melted the grease, but it got so hot that the grease inside these sealed bearings actually found a way out, and the bearings were running dry, so the bearings got wore out. So for sealed bearings, you know, nothing's ever sealed completely, because if it gets hot enough or damaged enough, it will ooze out. So, alright, let's see if we can get the other side out. We'll do the same thing. This time we're going to have to screw this thing in a lot farther. Somewhere there. You can see it sits right in the end right here. This part right here goes in there. And it's the same on the bottom side here. It's just going to go right in that little hole right there to keep everything centered. This one's probably going to be a lot more funner than the first one. If it goes easy, I'll be shocked. If I can hang on to it. I'm going to screw this down a little more. Okay, I have to set it up like this. Sorry for the bad view. Again, we try to grab the race on the inside only, or as much as possible, and be careful not to hit it hard up against these fins. It's kind of difficult getting all those in there, but because we don't want to break off those fins. Something popped, so it must have broke loose already. I can see it's moving up, so we're doing good. Again, it's tough with your hands like this, trying to hold it and turn it at the same time, but it's only tough for a little bit. I can see it's already starting to get easy. Alright. I'm to the point to where my bearing is actually hitting my tool. So that's gonna have to get rid of this little it's not enough to come off yet. These things here unscrew, but I don't know if we can use it without that, without damaging it. There is a little point on there too, but there's threads here, so you can't damage that, otherwise this is not going to screw back on. But that'll fit inside there. And it's not tough right now, so I'm going to give it a go. It was actually sliding pretty easy, so I don't think that we're going to end up ruining the threads on there. It looks like we're going to run out of room here. Well, that's no good either. So I guess what I'm going to have to do is, well, I might be able to go a little bit more. Maybe it'll pop off. But I have another smaller set of these. And it looks like I'm going to have to put that one together because it's not together yet like this one is. Yeah, that's about as far as that one's going down there. So this one bottomed out right here, and I needed this size to get this one off, but now I need a shorter, smaller one of these to get the rest of the way off, which I do have. I just have to take a break here for a second and actually put it together, and then we'll get back to pulling this off here. Alright, so I got a next smaller size one put together. This was the first one, and this is the second one. And I also took the little end off here so I can get this in there, because this will no longer allow me to reach that little hole down there. So we have to take that off. And if you are wondering, this is what I went out and got. So bought this at Harbor Freight, about 33 bucks. Pretty good deal. If you buy the 8-inch one by itself, it's like $17 just for the 8-inch one. And then it's like $26 for the other three. A 3-inch, a 4-inch, a 6-inch. So if you buy them all together in this 4-pack, it's only $33, so it's a pretty good deal. So, alright, let's see if we can pull this off the rest of the way. Hopefully, everything goes good. Like I said, it was almost off, but so it shouldn't be on there that tight. And there it pops off. Alright, we got it off. And here's the bearing. Yeah, this one here was the really bad one. You can I don't know if you can hear that. Little clicking noises in there. That's something going on with the bearings being bad. So that's alright, because we got some new ones. So now, since we got that off, we are going to take this project to my brother's garage, where he has a press that we're going to use to press these bearings back in. And that's what we're going to do in the next segment. So we'll see you then. Alright, so I'm here at the press for these bearings. I'm going to press them back on. Here's a little shot of what I'm using here. It's just a press that you can press on bearings. 20-ton. We ain't gonna use nothing like that, but this goes to show you what we're gonna use. It shouldn't take hardly anything at all to put these on. So I got 2 sockets, 2 different size sockets. It doesn't matter because the shaft, it's just the length, and that won't fit over it, but we're going to try to use it for this side over here. This one will actually fit all the way over it, but I'm going to use some washers here that just fit over it, and will cover the race, the bearing race, just perfectly. So I don't have to worry about pressing on the outside of the bearing. And I apologize for the lighting. There's no light in this part at the moment, this part of the garage. So I'm going to do the long side first. I already put the C-clips on there that we popped off. They're the stop for the bearings. You can see it on this side. I already put those on there. That bearing's all the way down where it's supposed to go. I'm just going to put some of these washers on there just to help, so it presses on the bearing evenly all the way around. Because you don't want it to slide down crooked, especially with this big of a punch. You won't be able to tell if you're going crooked. Okay, it's touching it. Just want to make sure I'm flush. Make sure everything is straight, because I don't want to push it on crooked. Bearing should go on real nice. I can see it sliding down. There's no pressure at all. I'm using 2 fingers just like that just to jack this. So there's no pressure at all pushing this back on here. And I'll do it until it just about hits the C-ring. Alright, right there is where I feel pressure, so I'm going to stop. And I'm going to release the jack. Take all this stuff off here, and that should be down far enough. It's hitting up against the C-ring, the C-clip there. So that's good enough for that one. No problems at all. Now let's try the other side here. I can start with just no help with those. I'm just going to jack this by hand. Guess it won't go down unless I tighten that. I did notice that this motor has a little bit of a bend in the shaft, and that could be why it wore the bearings out last time, and possibly why it might wear them out again. I'm not sure why the other bearings went bad or why the fan was in the garbage. So I'm just guessing at this point. But, all right, looks like it's straight. Let's just put a little pressure on there. It's going down. We're only going to be able to go down so far, and then we'll have to put a washer on there because it's going to hit the end of the shaft on this side. So, and that's it right there. And there's still just a little bit more ways we got to go. So I'm just going to lift this up just enough to put a washer in there. And the washer should be enough to get it the rest of the way down. Providing it's in the center. I'm just trying to hold it in the center because it has to go over the shaft. And there it goes. And that looks like it's all the way down right there. So again. And that's why we couldn't go all the way down, because it sticks up above that a little bit. But it looks like it's on there. So now we have both bearings back on there. We can go back to putting the fan the rest of the way together, and hopefully finishing this project up. We'll check the current like we did before with and without the fan blade on there, just to see how much more it draws because of the torque of the fan blade being on there. But here's this. All right, see you in the next section. All right, so we're ready to put this back together. Let's not forget to put our washers in the bottom, 2 plastic and 1 wavy. Of course, I have to drop it. Try that again. Alright. Have those in there. Get that in there. It doesn't matter which way it goes on, as long as you line up the holes. Alright, looks like it's closed all the way around. You can tell those bearings definitely feel snug now. My hands are kind of slippery. Alright, let's see what we have for, just before we throw the whole thing together, in curiosity, let's see what we have for current with the new bearings in there for all 3 speeds. So I have my meter already set on current on the 10 amp setting, and I'm going to connect my red to the power coming in. This red one would actually touch on each one of these, the low, the high, and the medium. But I'm going to use my black for my black lead because it's going through the meter so we can read current, and when I touch each one of these it should turn on different speeds and we'll take the reading and compare them to what we had last time. Alright, hopefully nothing shorts out here. Temporary. Turn the meter on, get that over to the 10 amp reading, put it on AC. Now let's plug this in. Alright, so now we'll start with the low, and the low before was 0.612 amps that it was pulling. Let's see if that changes any. About 0.68. So it went up a little bit with the new bearings, so there's more torque on there. So we'll just put this down at 0.68 for the low. Now let's try the medium. The medium before was 0.812. That's about 0.858, 56. Okay, so that's a little higher. So that's 0.85, let's just say 5. Now the high was at 1.195 amps. Here's the high. 1.222. So they all went up just by replacing those bearings in there, because they're new bearings, so they're not wore out, so it's not easy for the motor to turn over, so it requires more current. Alright, so I'm going to take this and I'm going to put it all on the pedestal, put the fan blade on, put the cage on. I'll still have these wires hanging out here, so with everything together, with our main thing that we was going to check is the current being drawn with the fan blade on there. And then of course after that we'll put it all together with the switch and see how the switch works too. So here's the fan all put together. We're outside in the garage. So I'm going to set this up to where you can see, you won't be able to see this part, but I'll shine it on the meter and you can see what the current readings are. It's going to be a little bit noisy because of the traffic, but hopefully we can get through that. So I'm going to test the low first and see what that current draw is, and then of course we'll go medium then high. So here goes the low. Alright, there goes the medium. still seeing a consistent increase on them. Here goes the high. Alright, there's the current readings, and that's about what the specs called for on there. It was 1.5 something, 1.6 something, and 1.9 something, so they're all pretty close. So next thing I'm going to do is I'm going to get the switch assembled in there, and I'm going to design on my 3D printer a little housing that can mount up here above the fan here, so all the wires can go into and the switch can go into to hold it securely. Alright, here's the results of the 3D printing. My little box for the power switch for the fan. This is the case. So what I got here is a little piece of metal. It slides inside the little groove that I made there. Slides up in there all the way. So that's the front. And then this switch will go inside, and then the two screws will go on there, and then our knob. And this will bolt to the fan. Well, let's see. Put the back on. That'll be the back cover, and then this will bolt to the fan with this little hole right here, just sitting up straight, so you can just turn it on to 3 different speeds. I got some wire here that I'm going to run through this little hole in the side. I'm just going to tuck it inside the little groove there all the way around. There's 4 spots. 1, 2, 3, 4 that the wires need to go to. I got some heat shrink put around the wires. It's all going to come out of this little hole right here, nice and tight. And then I put this on there, and then I got a 6-foot power cord right here. And we'll see if we can't get this fan working finally. Alright, so I'm going to do that, and we'll see you in the final section of this video. Alright, that's all I got for this video. Sorry about the length. I felt there was a lot of good information in here that someone could possibly learn from. I just have some images here of the switch on the fan itself. It works pretty good. I hope you enjoyed it, and we'll see you on the next one.